Hello, good morning, and welcome to today's webinar, Digital Transformation in a Quarantine World. My name is Richard Baker. I'm Vice President of Engineering with Prysmian Group, and I'm going to be your moderator for today's program. It's my pleasure to introduce today's three panelists. Will Berry is Senior Vice President with Southwire, where he's responsible for deploying the next generation of manufacturing. He has held progressively responsible positions at Southwire over his 39-year career there, including most recently Senior Vice President International and President of SCR Technologies. Welcome, Will. Bryan DeBois is the Director of Industrial Artificial Intelligence at Rovisys, one of the largest independent global system integrators focused on manufacturing and industrial customers. He has spent 20 years with the company and is currently focused on applying advanced technologies such as AI, machine learning, and analytics to boost the productivity of global manufacturers. Welcome, Bryan.
Thank you.
And Willem Sundblad is a Forbes contributing writer for Industry 4.0 and the co-founder and CEO at Oden Technologies, a company empowering manufacturers to make more, waste less, and innovate faster through machine learning and applied analytics. As a leading voice in industrial IoT, he is pioneering the use of real-time and predictive analytic tools that uncover untapped value. Welcome, Willem.
Thank you.
So, panel, our audience wants to learn how remote monitoring can be used for best results in wire and cable manufacturing. So starting with Will, and then moving to the others, I'd like to ask you, Will, to set the table by sharing a general overview of how you're involved in Industry 4.0.
All right, I'm responsible for Southwire's modernization, as Richard said earlier. And those efforts not only include equipment and process improvements, but automation and a connected enterprise as well. We're in the second year of a 5-year plan, so we're just getting started, especially when you consider that there's been a pandemic in the middle of it. We are improving the flow and velocity of product through our manufacturing facilities to minimize inventory, decrease delivery times, along with decreasing scrap and material usage along the way. At the same time, we're trying to error-proof our systems. Why should you allow the system to produce scrap or cause an injury if you know the correct parameters required to prevent them?
Thanks, Will. So, Bryan, what's your background and relevance to this discussion, please?
Yeah, so being a global system integrator, Rovisys is really involved on the front end of these engagements. We are there to help the customer frame the project, attach that project, connect it to ROI. We typically then design the system, bring in the relevant vendors that need to be at the table for a project like that. And then we actually have the whole engineering staff to implement a digital transformation project, kind of soup to nuts from beginning to end. And then we support the solution long term. So we work with vendors like Oden and other OT vendors in this space, and really design out the entire solution and are there for the customer from beginning to end.
Thanks, Bryan. And Willem, over to you.
Yeah. So, our job is to help manufacturers find the best actions to take and enable them to take them as fast as possible. So that includes, integrating and ingesting data from the different silos that are on the factory floor, provide the appropriate visualization so that you understand how you're doing and why. But then most importantly, leverage machine learning, applied analytics to really try to give you the answer, show you what's possible in terms of opportunity cost and also what is your optimal settings. And I think, we were promised an industrial revolution, but over the past couple of years, it really hasn't been a revolution. But I think the pandemic here has really been a big catalyst for a lot of companies because they've seen the very urgent need for remote monitoring for business continuity. So I think this is a very timely event.
That's great, and thanks for that segue, because we've broken the program into 4 themes. The first theme is adapting to a virtual operations environment. And we have a couple of slides that we want to share. The first one is really part of what Willem was referring to. It's one of the survey results of manufacturers where the vast majority of them have stated that their demand has changed in the past 60 days, whether it's gone up or down. They identified top challenges that they were facing. As you can see, minimizing operational costs, which the panelists referred to, managing supply chain disruptions, adjusting production to meet demand, creating a social distancing policies, and also enabling a remote workforce, which I'm sure the majority of people have been going through. So this slide is very, I think, revealing and gives a stage setting. The second slide we want to share is really that last comment that Willem made, the role of digital transformation. So 71% of manufacturers have said that digital transformation has increased in importance for them in 2020. And the top 3 aspects, as you can see there, are cost reduction by removing manual processes, improving quality by reducing process variations, and also real-time performance benchmarking. So with those 2 slides as the backdrop, I want to ask all of the panelists this question, which is, what are you doing to manage remote work and provide customer support while limiting your employees' exposure in this coronavirus world? So starting with Willem, would you give your thoughts on that, please?
Absolutely. I'll add a thought on the previous slide too, because the interesting thing, if you look at the top reasons why, or the things that they're focused on when it comes to digital transformation, those were all true before the pandemic also. But now we just have an urgent catalyst, because obviously you could use digital technologies to reduce your costs even before this. But it was always that, yeah, we will thing. When it comes to what we're doing now, I mean, obviously we're in a different situation than a lot of manufacturers, seeing as we're a software company. So physically, how we shifted to remote operations was a lot easier for us than if you have physical operations. But I do think that the most important thing, though, has just been communication and transparency across the organization. Because if everyone is working from home, you can't rely on the water cooler. You can't just stand up and shout in the office. So you have to be really focused and clear in all your internal communications, because otherwise people are going to forget who they work for if they're just sitting from home.
Yeah, agreed. And I think everybody would probably say email is one of our worst tools for communication. And the lack of the face-to-face and the contact really stretches the organization, right?
Yeah.
Bryan, what's your perspective?
So we're primarily, our customer base is manufacturing and industrial customers, and so what we're hearing from those customers is that most of them are operating with 50 to 75% of their typical plant floor operational crew. Okay, so they're already operating at a disadvantage. They're operating with smaller people on the floor, and then combine that with the fact that most of the office staff is typically not there. Most of them are working from home. And so you've got this situation where they're trying to do more with less. And then on top of that, if you're in certain industries like healthcare, life sciences, if you're in consumer packaged goods, food and beverage, you're actually seeing in some cases a spike in demand. So they're trying to, fill orders that are rushing in with fewer people. So obviously, again, it screams automation, it screams remote monitoring and digital transformation. So we have seen customers that have come to us and said we need to accelerate projects that were kind of already in the pipeline to try to manage the remote monitoring aspect. Another challenge that they're facing is the issue of maintenance staff. So a lot of these maintenance staff, I have very few customers that have a comprehensive maintenance staff at each plant. So they typically would share those maintenance staff between plants. Well, in a lot of cases, there's not a lot of movement right now. A lot of people aren't comfortable flying, and and crossing state lines sometimes requires a quarantine when you get back. So we're seeing some interesting things being done around trying to stretch that maintenance staff. One of the things is a significant uptick in augmented reality projects, where a more of a maintenance tech can hold up an iPad or something like that to a piece of equipment, and then a more experienced maintenance person who's remote can kind of highlight on the iPad what they're seeing and indicate okay, tighten here, lube up here, those types of things. Everyone's kind of trying to get creative and find ways to work with less and engage these remote workers in the day-to-day operations of the facility.
Yeah, that's really interesting. Really is. Will, what's your perspective from a wiring cable manufacturer's outlook?
Yeah, as Bryan said, we're just trying to get product out the door with the reduced staff. So, people who are normally in the office are working from home to minimize the exposure to those that must be in the manufacturing facility to service the customer. So we're trying to manage exposure for those people in the manufacturing facility. So we're using a lot of WebEx, a lot of Zoom meetings as we're doing here today, and to conduct our business. Also, we have implemented a wide range of COVID policies and procedures, including social distancing, temperature checks. Also, we have paid leave for people who do not feel like that they can come to work if they're experiencing symptoms. We don't want people feeling like they have to come to work if they feel like they're sick as well. So we're all about trying to get product out the door and service the equipment with fewer people in the manufacturing facility.
Yeah. I think that's a very common challenge that others have mentioned, but also has been brought up on the COVID-19 webinars that the Wire Association has run recently. That's very, very real perspective. Thanks.
And you can see how, the reduced workforce on the factory floor is, obviously an individual health and safety priority, but ultimately business continuity, because you've seen in other industries where they've had to shut down whole plants because too big of a staff got sick. And so health and safety of the employees is probably the most critical aspect to your business continuity right now.
That is correct. It's all about protecting the people on the shop floor.
Yeah.
Yeah, no question. Absolutely no question about that. Great. So I want to direct the next question specifically to Willem. It's relative to the perspective on smart factories. So Willem, we've heard a lot lately about industrial IoT technologies, and I'd like to get to understand how to best operationalize those in today's environment. So can you give us your perspective on the rise of smart factories, please?
Yeah, absolutely. I said in the beginning that ultimately it's about helping people take better decisions and actions faster, because value is only created when you take an action that is better and different than you did before. And so the merging of the domain knowledge of the people and the computational power of a digital system is what creates that opportunity. And it helps with reducing the necessary workforce on the factory floor, but ultimately it's cost savings for you. So step one is really connecting the assets so that you can find the data and find answers faster. That is step one. Step two, predictive analytics, where for both quality and maintenance issues, you can actually learn from the historical data to prevent issues from happening. Where we focus a lot is prescriptive analytics, where you both prescribe what is the potential ROI or outcome and what are the right settings to get there. And so right now, we're sending those recommendations to people, to process engineers that validate it. And then you make a change to the master process, or you tell the operators to make the products in a different way. The final step, kind of the AI-driven automation, is when you tie the loop from that recommendation engine back into the automation system, so you're getting a faster time to action. And so I don't think that we'll see in the immediate term, AI-controlled machines, because we want to keep the operators and people in the loop to validate and continue to learn, or reinforcement learning of those algorithms. But you don't need as many people to be involved in volume manufacturing. Those people's time and effort can be spent in other areas in the business to really drive new products, more customization, shorter lead times, etc.
Yeah. So, Will, I'm sure that you've got machines on different levels through this pyramid that that Willem was describing. So, what sort of operational decisions need to be taken into account when you're considering implementing industrial IoT technology?
Yeah, so like I said, we're kind of early on in the process. So, we are more about the data right now, more so than the analytics. So for us to get started, the number one thing required is that executive leadership support. And the reason for that is typically the cost to begin an industrial IoT solution in operations are high with little value, especially when your MES and SCADA systems are not truly interconnected. A lot of money has to be spent on what we call infrastructure before you can ever get to the more sexy kind of AI and augmented reality and those type things. Right. And so while you may see many success stories, as Willem will talk about, around AI and machine learning, these do not occur without that historized or validated data. And companies need to start small, learn fast, and evaluate how those learnings can scale across the organization. So real quick, I want to go through 3 areas that we're kind of focused on. And, always remember that you're trying to get the right information to the right person at the right time. So when you talk about the operator usually requires real-time data to run the process, but wants predictive data to make their job easier. When will the take-up be full? When will the payoff be empty? How much compound is left, and how long until I have to change color, as well as what is the next job coming, and what material do I need to complete the order? So make my job easier if I'm the operator. For the manager, usually requires historical data for their updates. They want to better understand how the process, plant, or company is performing. Are we running at the correct speed? Are we consuming the correct raw materials? Are we making the product or bad? And what are the variances? And then the third area that we are looking at is the engineer. And the engineer wants to have historical data, but needs to use this data to predict, what data and analytics are required to solve the problem. How do I reduce the standard deviation? When do I need to replace the bearing? What is causing the defect? So they're trying to use historical data, but predict scenarios out there. And so also the IoT solution needs to be coordinated with the goals of operations to improve the manufacturing process. We suggest a dedicated team to manage and drive this initiative, but they need direction from not only manufacturing, but also quality, safety, maintenance, and those support here.
Yeah, no, those are very, very, very valid comments, Will. Very valid. And it leads into the question I had for Bryan, because without unduly disrupting operations, but also delivering value quickly, what are some of the applications or use cases that manufacturers can apply either as pilot projects or entry points before a broader deployment?
Yeah, for sure. Well, and I'm so glad Will and I did not compare notes before this, but that's exactly the direction I was going. So I was so glad that he talked about that. I think that the base of that pyramid that Willem showed is about data connectivity and data collection. And so to Will's point, that's a great place to start. And it does not have to be disruptive to the day-to-day operations. To put in a process historian typically is a pretty hands-off type of operation. It doesn't really affect any of the running equipment. You're gathering the data from it. In some cases, you need an IoT play because you may need to put an edge device or something out there to gather the data. But in all cases, you can pull that data into the historian and start to get immediate benefits and value out of that data. And then once you've got that data in the process historian, there's a reason why OEE is the #1 KPI that we're asked to implement, right? So OEE is a great place to start. There's 3 components: availability, throughput, sometimes called performance, and quality. So availability, throughput, and quality. You know, if you just hook up the machines to a historian and start looking at the data as far as how the machines are performing versus their specs, you immediately get a throughput, you know, reading on that. So right away you can start to make some modifications and adjustments there. Then if you add in the ability for operators to indicate why certain downtime has happened and start to add those reason codes for certain downtime incidents, now you can start to get to availability. And now you can start to do things like Pareto charts, you know, for why certain piece of equipment. And again, at this point in the game, all we've done is we put in a historian that's monitoring this data, and we've put in some pretty easy to use user interfaces for operators to qualify why, you know, why certain events have happened. Quality gets a little more intricate because you do have to start to mix in results from LIMS systems and things like that. But again, this is a great place to start. And then when you get to the point, as Will was talking about, when you get to the point of trying to apply advanced analytics and AI and ML, those vendors are going to tell you we need all that data, that historical data anyway. So it's not like it's a waste of effort. I mean, you're really, all you're doing is you're taking that first step towards that AI and ML implementation. So it's a very worthwhile thing to do right now.
Yeah, I was going to say, not only is it not a wasted effort in terms of the data that's being collected, but you do get incremental ROI on each level of that pyramid. And oftentimes, especially like the connected level, might be the easiest way to get ROI, because I've seen a lot of customers that say that, you know, you get 15 to 20% bump just by implementing it, or even telling people that you've implemented it, because they're going to adhere more to standard operating procedures.
And anecdotally, we have seen that exact thing happen. Just increasing that visibility into the operations has given you that bump in productivity.
Yeah, absolutely. Great, thank you. I want to move on to the second theme that we identified, which is really equipment diversity challenges on the shop floor and how to overcome interoperability challenges. So it seems as though, you know, leveraging Industry 4.0 and IoT solutions requires the latest equipment, but, you know, most people, they have equipment from with different protocols, different ages, different connectivity, and it's not economical to rip and replace everything in the factory. So how can companies make sure that everything, both old and new, works together? And Willem, maybe you can kick this one off, make some comments on this, please.
Yeah, absolutely. I think, you know, every manufacturer is going to have a pretty wide distribution of the age of equipment and a lot of other sources. That's just that's par for the course for manufacturers. But connecting machines is a very known problem, and there are a lot of vendors and solutions out there. You know, companies like Rovisys, etc. I've seen the most success where companies kind of focus on the standards that are growing the most. So focus on getting it to a standard OPC server, or focus on MQTT, because you're kind of future-proofing the way that you're setting up that base level infrastructure. So there are great tools like, I would say, Kepware, that can communicate with many different protocols that kind of solves that equipment diversity and can bring it to a standard unified format. It takes time and effort, but you have to do it.
Absolutely. Will, I mean, in the wire and cable industry, you know, you and I have been in it, you know, 40 odd years, and some of the equipment we've got is older than us, which says something. So, you know, what are some of the challenges that you see about the protocol and matching with the ages of equipment.
Yeah, and I agree that we've got a wide range of ages of equipment, but you need to determine and target and focus on a certain number of machines. Trying to find one solution for every piece of equipment, it's going to limit the ability to move forward quickly. And, always remember, you need to start small, learn fast, and evaluate how those learnings can scale across the organization. We started with a high-level evaluation to determine what equipment will be most beneficial and find a solution that will work across those multiple platforms. While there are solutions that can connect to a wide variety of devices, companies should set standards on the communication from the equipment to the IoT solution. This will apply to connections for new equipment as well as the gateways needed to connect to existing legacy equipment and even future equipment, because you never know who you will acquire in the future and what they will have.
Yeah, absolutely.
Yeah, and one thing maybe to add to that, because I think that you raise a very important point, because if you're just looking at what does it cost to connect a machine, you might not really be looking at it from the right way, because you really should be looking at it in terms of what's the business case that you're trying to solve. And there are going to be machines that are going to be cheaper and easier for you to connect. So start there to prove the business case, because then it's going to be way easier to get the payback on the ones that are maybe a little bit more troublesome.
Yeah, absolutely. Bryan, you're nodding heavily in agreement there.
Yeah, absolutely, absolutely. I mean, and so we go into these projects effectively, assuming that we can't rip anything out. I've got a great story around this. So we've got a steel producer who has a powerhouse that was designed and installed in 1905 and by Edison's company. And there's still a turbine, a steam-powered turbine that's in operation in this powerhouse still today, 115 years later. The original drawings and schematics still have Edison's stamp on it. And over the last 115 years, it's been retrofitted over time. And so now we have a digital modern SCADA, computer-driven SCADA that can control this steam-powered turbine. And that's kind of the world that we live in. When you go into the control room, you've got the modern SCADA, and then if you walk over, there's an old 1970s, NASA style, metal panel with a schematic of the whole powerhouse and lights and switches to control the things. That was from that era. Of course, every time they do an upgrade, they don't want to touch anything, so they just leave the old controls there. And then past that, you have a giant slate table with two levers that control the operation of the steam, boilers powering the turbine, and so that's kind of the world that the manufacturers live in, and so we very much embrace that, and there's lots of things we can do to instrument and retrofit some of this very old equipment to make it part of a digital transformation story.
Cool, that's an interesting story. So obviously lots of opportunities to collect data from machines, sensors, MES systems, quality data, and more. So Willem, in terms of machine learning and how that builds into the fundamental building of data, what is a typical machine learning workflow? And there's one up on the screen right now. Maybe you can talk to this and give some comments on it, please.
Yeah, absolutely. And I think the most important thing is to really look at the business case first, because you can almost think of it as a multi-layered Venn diagram of like what's important to the business, what can machine learning do, what can my data allow me to do, and then that's really where you should focus. But so focus on really delivering ROI and creating a meaningful project, because that's going to help you identify the data sources that you need and also the people that are going to be influenced by those results. The data needs to be cleaned and processed, because you might have it not really structured with the right units or names or naming convention. the critical piece here is really in the training and deploying machine learning models, and that you want to have a very fast iteration cycle on that. Because machine learning models are becoming more and more commoditized, and there's a lot of open source things out there. But the trick is to be able to continuously learn and adapt and reinforce that learning based on your own data. So you don't want to have weeks or months long processes. You want to have in the order of hours or days in order to build and deploy new models. And you want that to happen both in the cloud or on the edge. And when I say edge, I just mean that the processing happens on the factory floor so that you can rely on it in real time. Ultimately, it has to be brought back into real actions that people can take, because the value only comes when people take action. And then there's just this continuous loop. So while I agree with what Will and Bryan said, that you have to start with that infrastructure and that connected level, because that collects the data, you can move to machine learning reasonably quickly as long as you've got the right use case and the right data. For something like we do with Golden Run or optimization, you need 1 to 3 months of data, which isn't that much at the end of the day.
So Will, you mentioned this a bit earlier about collecting the data, and as we know, we can get overwhelmed with all the data we've got, and drawing the relationships between it is very difficult unless you've got the right tools and support behind. So how do you get more granular to avoid the data collection becoming overwhelming? How do you determine with your group where you start? And you mentioned a little bit before, but maybe you can elaborate on that.
Yeah, and it goes back to what Willem said a little earlier. We feel like you need to start small. Choose a project, choose a small project, ask knowledgeable people to make an educated guess on the data required, use the 5 why approach to root cause analysis to identify the necessary data. Then start capturing this data, and then analyzing the data captured. If the questions cannot be answered by the existing data, then identify other data points that need to be captured as well. So it's an iterative process. You're going to have a bunch of data, and then that data will probably generate questions that you can't answer because you don't have some other data. So then you look at installing and putting in measuring devices or putting in a way to capture that additional data to further enhance the analytics and try and get to the root cause of that problem that you're trying to solve.
How do you deal with noise, the data noise? Because in a lot of cases, there's data out there that really isn't useful to you. So how do you get selective about that?
Yeah, and that's one of the problems you run into is sometimes you want to collect all the data. And I think before you just start capturing it, you do need to ask some questions about it. Is it really valuable? Do I need to collect it? Especially if you've got to install additional devices to collect the data point. Make sure it's really necessary, because if you don't, then you can delay projects and delay the analysis required, and you won't see the true benefit early on. So you got to be a little bit careful with the data, but I think if you start small and you use an iterative process, you can really hone in on the data, most important data required.
So Bryan, Willem earlier was describing the machine learning cycle. How can machine learning technologies really help manufacturers become more efficient? What's the bottom line on that?
Yeah, so when Rovisys started this industrial AI division, that was one of the first questions that we asked, right? Was how can we apply this technology, and where's the best places to get a fast ROI on this? So we talked to manufacturers, kind of early adopters that have started to dip their toe in this. We looked at some of the metrics that were out there, and we boiled it down to about 4 primary areas that we're focused on that we think are the low-hanging fruit for applying machine learning to manufacturing. The first of those is predictive quality. And we actually think that moving the needle on this is going to probably have the biggest impact on the bottom line, because you're making product all the time. So compared to things like predictive maintenance, where you may have a failure, hopefully, only every 6 months or 6 weeks, in unplanned downtime, every day you're making product. So if you can increase the quality, the yield, reduce scrap, those types of things on a day-to-day basis, you're going to move the needle every day effectively. So the first is predictive quality. The second is predictive maintenance, and that gets all the hype, and there's all the sexiness around predictive maintenance. And there's some great platforms that are pretty turnkey to handle that, that particular use case, and still absolutely worthwhile to pursue. The third one is predictive set point. So that's where you're actually digging into the process, and you're trying to get to a point where the machine learning algorithms can see all the inputs to the process, can see the final quality that was produced, and can start to make some educated guesses as to where set points maybe should be changed. To Willem's point previously, though, we are not seeing a use case, at least right now, where you're going to push that set point down into the controller automatically. We're still hearing vendors that are kind of pushing that story, and that this is a place where we kind of part ways with those vendors and say, no, we're not going to do that. What we think will happen in the short and medium term is that the machine learning algorithm will say, hey, this set point's 82, it probably should be 85. And then in a weekly engineering meeting, someone's going to say, hey, the ML algorithm thinks we should change that. What do we all think about that? Yeah, okay, let's try that. And then a human being's going to go and make that change to the PLC. And so that's going to be the story for the short and medium term. So, but predictive set point definitely is somewhere where we think. And then the fourth one is anomaly detection. Effectively, training the ML algorithm what normal looks like, and then having it watch for when things start to go, non-normal. So those are the four areas that we're focused on right now.
I wholeheartedly agree that predictive quality is, I'd say predictive quality and actually predictive set points, you can drive so much value so quickly, and it's also because the data is just available so much sooner. A typical rule of thumb when you want to build a truly predictive model is that you want 10 times the examples of something that you want to predict compared to the variables that you're analyzing. And so if you've got machines that are running all the time and you've got quality failures daily, then you're going to build up that data set much faster than if a machine breaks once a year.
Absolutely. And to kind of build on that, one of the things, the struggles for certain manufacturers is that depending on their process, they may not see quality. I have a customer who ships products before they get the quality results back from the lab because they're in a sold out industry. So they know that the customer is going to recheck it anyway. And so they're shipping product, not a best practice, but that's the reality of the world they live in. So depending on the industry, sometimes the quality results are very, very delayed and can cause a lot of bottlenecks. So if we can get those quality by predicting what the end quality is ultimately going to be based on the process parameters, if we can get that quality in the hands of decision makers faster, they can make much better decisions. That particular customer, they handle it on the back end and have something like $1 million in returns every month based on where the quality actually ended up. So that's something where you can immediately move the needle for a customer like that.
And so I really agree. You want to do that, the offline tests. You want to predict those in real time. A very common problem within that specific use case is also that you don't know where the sample was taken. But with machine learning, you can actually infer where in the process that sample was taken, because whoever took the sample from the product didn't actually jot it down in the process data or the time, or maybe it's not really accurate. But you can find in the pattern of the data, given enough data, where that was, so you can truly solve that problem for good.
Right, good. So panel, moving into our third theme, one of the things, you hinted at it, I think Bryan said it as well, the machine learning, it's going to be a human interaction in a lot of cases. But, there's always been that age-old saying, oh, the computer's going to take my job away. So, from the three of you, and starting with Willem, how do you address the fears and concerns that you meet in an operation to build a digital culture onto the factory floor? What are some of the overcoming techniques or tools that you use?
Maybe I'll start by saying, how did the Luddites do? Because ultimately, as an individual, yeah, exactly. As an individual, you don't really have a lot of power to stop the change from happening, because there is so much value to capture here, and your competitors are going to do it. What you as an individual have the power to do is to embrace it, become a champion of it, and really augment your own career. Because there is so much career opportunity here. If you actually embrace the change and you are the internal champion, you learn the tools, you learn the technology, or you learn how it should be implemented. Because ultimately, the machine learning and AI technologies isn't valuable on its own. You need the domain knowledge of the actual process. What's valuable is when you combine the people on the factory floor with these technologies so that the combined solution or the system becomes more powerful. So maybe that's a hard way of saying it and calling them Luddites, but I really think that there's so much opportunity for individuals here in actually embracing this. And we have seen that, especially process engineers, sometimes people who aren't process engineers are worried that the process engineers will think that their job is going to be replaced, when the process engineer is the one that is the most excited about it.
Right. Mm-hmm. Right, understood. You agree, Bryan?
I do, and I understand the fear. I understand the concern. I work alongside these operators on a day-to-day basis and talk to them, and I understand that. What I'm actually seeing though is kind of the opposite issue. Most of my customers that I talk to feel like they can't get enough people to work. They can't get enough operators. I've got a customer right now that's looking at robotic machine tending for CNC machines.
Of
money on doing that, but because they can't find enough people to fill their shifts to do machine tending. Now, if we look at a job like machine tending, I mean, it's not the sexiest job, right? You're pulling a blank out, you're putting it in a machine, and then you're waiting, and then you're pulling out, the part, maybe doing a hand inspection or something like that. But it is a job, and it's a decent paying job, and so. So really, that's been more of what I'm hearing from customers, is that we can't get enough people. So they're looking to digitalization to give the people that they do have an opportunity to work on higher value tasks, and that's really what it's about. I see digitalization as giving humans the chance to really show what we can do and how much better we are, frankly, at problem solving very complex, problems than computers in a lot of cases. So let's empower, those humans to do more and to do those higher value tasks.
What's your thoughts, Will?
Yeah, so very much the same as Willem and Bryan just said. We're not looking and talking about reducing headcount, but we are talking about doing more with less. We need to be able to produce more wire and cable with the same number of people. And, because just 4 months ago, pre-COVID, we were facing workforce shortage. I mean, employment was tight just 4 months ago. And so people will continue to be a vital part of our manufacturing process. Yeah. What we want to do with Connected Enterprise is about removing the frustration people face doing their job. Back to that, we want to get information to the right person at the right time. And so, we need to focus on presenting real-time, actionable information and clear recommendations to those who can have the greatest impact on improving the results. This effort should be about automating actions to reduce errors and issues, as was mentioned earlier. And where automation isn't possible or feasible, it should focus on providing better data for better decisions. Reports for yesterday's decisions are 24 hours too late. You need the information today to make decisions today, not yesterday's information to make decisions today.
Yeah, Yeah, that's exactly. So,
I
Willem,
would add a macroeconomics perspective on that one as well, which is if you look at some of the supply chain issues that we had in the US over the past couple of months, is because we have industries or factories that have moved overseas. And when you have a pandemic, that opens up a really fragile environment for everyone. And in those instances, what's happened is that we can't compete with low-cost labor countries if our labor contribution to the cost of goods sold is too high or too big of a component. And nor do we want to, as a country, compete on having a lower wage. We want to compete on having the best products and the best manufacturing processes. And so decreasing the cost of labor in the direct cost of goods sold is critical for our competitiveness as a nation.
Yeah, absolutely. Yeah. So, Willem, you're and your company are very familiar with the wire and cable industry. So, what sort of knowledge or expertise is really needed to deploy these solutions?
So, I mean, we have a lot of experience in wire and cable, but we also work with a lot of other industries, and we never claim to be wire and cable experts. We're experts in software and data. So I think that the domain expertise is really what the customer has. And so the trick is to codify the domain knowledge of the people into the taxonomy of how you analyze the manufacturing data so that you can do it in a templatized and scalable way. So I think, for a manufacturer, the thing that you need to know is about your process and then work with the right partners and vendors. Because I do think that through this whole transition or evolution, revolution, whatever you want to call it, you have to be very smart about what type of skills are you going to invest in, because you can't invest in everything. Mm-hmm. But knowing how you make your products is the thing that will always be your IP.
Mm-hmm. Yeah, absolutely, no question. The fourth and final theme that we wanted to just cover is, okay, so we're on this digital transformation journey. What are the tips for the road? So, Will, if everybody's using this approach, these technologies, how do you strengthen or build a new competitive advantage, do you think, with the use of these technologies?
Yeah, so using these technologies to me is very similar to using the equipment that we all own. Just about all the wire and cable companies own the same equipment, usually from the same manufacturer. So it's not owning the equipment that's important or owning the technology that's important. It's how you apply that technology. And, we've got to decide what to focus on, how much effort and attention to give what we're focused on, and what strategy to employ. And so that's going to involve everything from funding, organizational priority, resource allocation, standardization, where to leverage the technology, all of those things that you do today with the piece of equipment that you purchase. I always use the analogy, I'm a golfer, and just on the same golf equipment as Tiger Woods doesn't mean I can play like him. So, it all depends how you apply your knowledge and your strategy to what you own.
Yeah, absolutely. Yeah, it's the person hanging on the end of the golf club that affects it, right? So Bryan, getting started or even getting restarted, if people have had a failed attempt, what sort of advice would you share to help a company get going?
Well, the good news is that whether you're starting a project from scratch or you're starting over, my advice is the same, and it's twofold. The first one is that make sure that you're connecting these projects to actual business needs. One of the first questions when we have a customer that approaches us and is immediately starting to talk about technology, the first thing we do is we go, okay, but wait, let's step back. Why are we doing this project? What are the outcomes that you're trying to get from it, and how do they connect to business needs? So make sure you have a solid ROI case. And then the second piece of advice is just like Will mentioned earlier, start small, phase out your approach. Do not try to swallow the elephant in one gulp. And what's interesting is that actually runs counter to the advice that the real big consulting companies will come in and say. They'll come in, the big 4, big 5 consulting companies will come in and say, give us $15 million and we'll solve all your problems. And we've been pulled into those projects, 10 million into them. And there's not a lot to show for the money that's been spent. So
to reduce your costs even before this.
Start small, get some quick wins, look for the low-hanging fruit, and then ride that momentum of the first win into the next one and into the next one. Everyone wins then. The executives win because they're showing value for the money that they're investing. The operators win because they get to see this incremental improvement in their day-to-day operations. It's just the better approach to approach this thing. So if you follow those 2 pieces of advice, you at least are starting out on pretty solid footing for those projects.
Cool. So those are the 4 themes that we wanted to work through, but we're going to have a look at some questions in a minute. But before we do that, could each of you, a closing thought, maybe something we discussed, maybe something that we didn't, that we should have. Something that people should be aware of. So maybe Will, you can make a couple of comments, please.
Yeah. So when you talk about data, I always get nervous because you'll be looking at a screen and you'll look at this data, and the operator will not be running the equipment at the speed he's supposed to be running, or he's using more raw materials than he's supposed to use. And the first thing you want to do is go blame the operator. And that is where I get nervous. That's the worst thing that could happen. And so that's where the analytics are so important. And you've got to go through that analytical process to determine why that operator isn't running at speed or is using more raw materials, because that operator is out there to do his job and he wants to do the best job he can. So, there's another reason beside the operator that the data is what the data is. And so I get nervous that people will want to use a club before analyzing and determine why the data is what it is.
Agreed. Yeah, absolutely. Bryan, your thoughts, anything that we should have covered or reflect on?
Well, I think, and Willem mentioned it very briefly, but I wanted to emphasize the point that make sure if you're at the point you've got the data collected and you are starting to build ML models and you're starting to look to adopt AI, make sure you have a plan to operationalize your AI. I think the reason that why we're seeing what's called POC purgatory, a lot of these AI projects never get out of the proof of concept phase, is because they build a model and they may even have good metrics on what that model is, the predictive power of that model. But nobody on the team had any idea on how to actually move that model into a 24/7 operating manufacturing facility. And what are the procedure changes, the human factors that are going to be affected when you've got this model in place and making predictions about what's going to happen on the plant floor. So if you're going down this road, make sure you're asking your vendor or your system integrator that's part of that project, make sure you're asking them, what is your plan to operationalize this AI model? And what will the state of my plant floor look like when this model is actually in place and operating down there? So.
I've never heard of POC purgatory before. I'm glad you explained.
POC purgatory, yeah.
Willem, any closing final thoughts from you, please?
I think that maybe the only thing we didn't touch on, which I think is actually absolutely critical in success here, is just leadership. I agree with the approach that we've talked about. You need to have the business case, you need to prove it, you need to scale it up because that builds champions. But really, you need leadership to be bought in and have a vision that this is going to be important for the future. Because I think that, there's a lot of turmoil going on in the manufacturing industry right now. Demand is changing in different industries, but this is a really interesting and exciting time for manufacturing in the US, because I think that we're going to see a lot more activity. I think we're going to see a lot of industries coming back and being more powerful in the US. And these tools and technologies with the right people are going to make all that happen.
Yeah, absolutely. I think, Will, you also touched on that in some of your early remarks about having the right leadership structure in place and also the team focused team work, right?
Yes, you've got to have executive leadership support to make this work.
Absolutely. So we have a couple of questions, or at least we have one question I can see here. Not sure yet who to direct it to, but I'll read it out and then we go from there. So an IoT application adds value both to the user of the machine and to the OEM, and also other players along the value chain, i.e. electrical motor manufacturers. What is your opinion about openly sharing the data throughout the complete value chain?
I've got opinions on that.
Go ahead.
Share? Okay.
Yeah, go for it.
So I'm just gonna use Southwire as an example here. So if Southwire has the system, Southwire owns the data. If Southwire chooses to share that data with the OEM, they should do so, but they should do so in a way that they get something in return. That's where you get kind of the macro learnings of machine learning that can be really valuable. So if the OEM can actually get the data from all of their customers to deliver a much better predictive maintenance algorithm, that is valuable for Southwire and for Prysmian and for everyone else, because you get the true network effect of that larger data set that is better than you individually companies can get yourself. And so I think that the data should be controlled by the end user, because you're the one who's buying the machines and everything else. But there are macro learnings that are valuable for everyone if it's shared, and it can be on an opt-in basis. Because if it's done on an opt-in basis, then everyone knows the benefit that they're getting of doing
it. Bryan or Will, do you have a thought on that question?
Yeah, I agree with Willem that there is data that a manufacturing company has that they have to protect. There's some know-how that has to be protected, but I would say that's a small percentage of data. The more data you can share on general items, then the better off you will be, and it'll also make the industry.
Mm-hmm.
Right. So we've got a second question come in. I heard mention standards such as OPC and MQTT to ease interoperability between systems. Going forward, would you recommend that machine builders focus on providing data using such standards? Any other low-level standards recommended?
Yeah, I could probably address that one. So 100% yes. You're going to make, as a system integrator, you're going to make my job a heck of a lot easier. And that's also a differentiator. I think OEM equipment manufacturers are in an interesting place right now because it's starting to become a race to the bottom in terms of pricing. Everything's kind of becoming a commodity, and so they're looking for ways to differentiate themselves. So I think OEM equipment manufacturers who are forward thinking, that are exposing that data in standard formats, and there's several out there. PACML has one. SESME is a group that's starting to standardize some of this stuff. If you're providing that, as a value add, then that's going to help differentiate you from some of your competitors. So I would say absolutely yes, they want to start looking at that.
And I would add, so like right now, certain OEMs are still charging quite a lot of money to enable OPC UA communications in a software update. I think that's going to go away, and I think that there's a big opportunity for OEMs to just remove that as a competitive, advantage. Because
Absolutely.
People are really frustrated in paying $5,000 for that software update that enables that. And ultimately, the ones that are the easiest to integrate with are the ones that are going to get the biggest uptake.
That's right.
Yeah, good. All right, so I got another question. Once you've collected data, where do you store it? I mean, data are valuable and memory may become an issue for statistical data and go into machine learning.
I can start. I think there's two sides to this. So you want to have a certain amount of data in real time on the factory floor so that you can run things in real time like machine learning, but you don't want to do long-term storage on the factory floor because it's just cost prohibitive. So I mean, all the main cloud providers have made storage of data ridiculously cheap, and you're not going to be able to do it cheaper, and you're not going to be able to do it more securely than they can. And so to have a cloud edge hybrid architecture of your storage is the most cost-effective way of doing it, and it's also the most powerful way of doing it and the most secure way of doing it. Because if you just have it in one data center in one factory, that again is a risk to business continuity.
Right, absolutely.
Yeah, and so on-premise historians also are still an option. They are more expensive, as Willem mentioned there, but you absolutely can store all that data for, most modern historians, they're looking at 10 years of online data. So you can get instant results on what happened in a process for over 10 years. And then there was something about data stored in memory could be lost. All modern edge devices, all modern historian interfaces, they all buffer data to disk. So there's not really, that 20 years ago, that was maybe a real concern, but anymore, everyone understands the value of that data. So it gets buffered. So if you lose connectivity or a power outage or something like that, the data is all safely written to disk or flash memory and can be uploaded when connectivity is restored. So.
Right. Here's an interesting question. In a remote manufacturing world, are there any considerations being given to liability, either personnel or machine, when processes are done remotely, or are we looking at? Hang on, this is not scrolling properly. Are we looking at monitoring only? This is the question as it relates to internal functions and how it relates to your suppliers. So, liability. That was the question. You want to have a go at that one, Will?
Yeah. So, you definitely do not remotely operate equipment if people are around, and unless that person has total control over that remote operation. So that I would say you don't do. There's a lot of safety involved. So I would say monitor is the approach you want to take.
Yeah, and I'll add to that. So the example of a machine learning model actually controlling machine, we've done that in a proof of concept, but that is not how we in the future will productionize that. You want to have a person on the factory floor that actually approves, rejects, or adjusts any new setting in order to make sure that you're capturing their domain knowledge and everything else that's going around in the factory, and that they can validate it. You don't want to run a machine from your couch, because who knows if your kid picks up your iPad computer or whatnot and increases the speed. There's just the security gap there is very large. So yeah.
And I would just add, we are having customers that come to us that are a little confused, and they're asking about lights out factories and things like that. And we've seen that. We've certainly helped data center companies build lights out data centers, and that makes a lot of sense. But in a factory type of setting, we still kind of think that's pie in the sky, not really a very reasonable way to operate a factory. So we don't see it in the short or medium term, this lights out factory concept.
And the lights out factory doesn't mean that there aren't any people there anyways. I visited a factory in China that was reasonably lights out. I was in an injection molding facility, and I think you had maybe one operator or technician for like 100 molders.
Right.
And he was going around with a flashlight. But he's still there to actually make any changes that are necessary.
Right. Yeah, I think it's more about scaling operations with fewer people than really trying to actually have an empty factory. And I think that's what's maybe missed by some of those customers.
Yeah. Right, we have time for one last question. Throw this one out there. Can we have universal sensors for capturing the data for different components of a line or wiring cable machines? Or do we need to go to the OEM for the sensor, as as typically they are costly for implementing AI.
Can we have universal sensors?
Well, I guess the question is like bolt-on retrofit sensors rather than universal, maybe, because universal then I think something that senses everything, but like a retrofit sensor that you can put on your machine yourself. So I guess the only question is, are you going to be able to, if you are going to put the sensor on yourself, which you can certainly do for vibration and sound and other things, you just want to make sure that you're also calibrating it, and that if you want to do it for 10 lines, are you putting them on in a uniform way? Right. You can certainly do. Maybe not for everything.
And I would say, I mean, we're seeing more and more of these sensors that, because the IoT movement sensors are starting to flood the market, and that's great. And if there's a market there, someone will find a way to sell it. I will say though that, most of our customers are still kind of leaning on the side of traditional sensor vendors, and yes, they're more expensive, but they're hardened. We're not seeing customers who are super excited about putting, say, a USB-driven sensor out on the plant floor, especially if it's an acoustic or dangerous or dusty environment. And so, I think there's a balance there in terms of this drive towards cheaper and cheaper sensors, but also then there's an aspect of it's got to run in a 24/7 hardened environment, and what do we really want to do there? So,
yep. Okay, well, look, our time is up. I'd really like to thank you guys, Willem, Bryan, and Will. You've been great today. I appreciate it. I hope people on the call have learned a few things. Your insights have been very valuable. I'd also like, on behalf of the Wire Association International, to thank all of the people who attended this webinar. I was checking as we're going along. I think I saw 148 at one point in time. I don't know if that's what it maxed out at, but that's the one I saw. What's next is that we'd like you to join us for the next webinar series focusing on non-ferrous and electrical sector, Wednesday, the 24th of June at 11 Eastern Time. 3 special topics directed to wiring cable manufacturing professionals, including sessions from Jem Gravure, Delta Technic, and Horace Potts Consulting on wire break. So check your email in the next few days to get the heads up on that. And then on July the 15th, the Wire Association is going to hold its first ever wire and cable streamcast. This should be fun. And it's a live broadcast. It's going to have 10 sessions featuring a combination of presenters, from a keynote address to subject matter experts to guest speakers from exhibiting companies. There's going to be a raffle. People can win prizes. Raffle winners selected from the virtual audience, and speakers are being scheduled now, and they'll be revealed at the day or closer to the day. Space is limited for this event, so sign up. So this brings the WAI's presentation today to an end. Thank you once again, and have a good day. Be safe.
Thank you, everyone.
Thank you.
Thank you.